share the world. This is Angela P.D. Altesa,
And this is Joanna Clarice Aguilar,
serving everyone facts and knowledge here in Biomass 80.45.
for today's headline.
Students at University of Nueva Cáceres were unraveling the mystery of digestion and absorption of carbohydrates, diving deep into the world of science.
Heads up as a student of University of Nueva Cáceres unveils the wonder of glycolysis, decoding the engine of life at microscopic level.
UNCians never back down as they explore beyond glycolysis, unveiling the intriguing fate of pyruvate.
Knowledge unlocked. As the Unicians discovered, the digestion and absorption of carbohydrates is a complex process that begins in the mouth and continues throughout the digestive system, with three macronutrients along with proteins and fats playing a crucial role in providing energy for the body.
How's that, by the way? They also mentioned the process of digestion and absorption of carbohydrates. In their gathered studies, specifying that digestion begins in the oral cavity or mouth, where the enzyme amylase is secreted by salivary glands, and this enzyme catalyzes or speeds along the hydrolysis of the starch molecule, where it begins breaking down complex carbohydrates into simpler sugar such as maltose.
They highlight here that the initial breakdown is an important step as it starts the process of converting complex carbohydrates into forms that can be absorbed by the body. As the food travels to the stomach, the acidic environment temporarily halts the actions of salivary amylase. However, the digestion continues in the small intestine where the pancreas secretes pancreatic amylase. This enzyme further continues the breaking down of complex carbohydrates into maltose and other disaccharides.
And today, we have a special guest, Ms. Velasco and Ms. Casas, two of the students who conducted research about digestion and absorption of carbohydrates, who will explain further for us to understand the process of digestion and absorption.
Thank you for being here with us, Ms. Gasas and Ms. Velasco. Could you tell our viewers who's watching today the research that you guys conducted? We've been looking forward to hearing every detail.
First of all, thank you very much for having us today, and absolutely we are happy to share it with you guys.
So we did a research about the digestion and absorption of carbohydrates, where we found out that carbohydrates digestion occurs at the back border of the small intestine, where enzymes like maltase, sucrase, and lactase break down disaccharides into monosaccharides. The primary monosaccharides resulting from this process are glucose, fructose, and galactose. Once carbohydrates are broken down into monosaccharides, they are absorbed through the walls of the small intestine and enter the bloodstream. The absorption process involves the use of the specific transporters to move monosaccharides from the intestinal lumen into the entire space.
And we've also discovered that after absorption, monosaccharides are transported via bloodstream to the liver, where they may be stored as glycogen or released into the bloodstream for energy use by various tissues. Excess glucose can also be converted into a fat or a long-term energy storage. Carbohydrates, particularly the monosaccharides glucose, provides your body cells with an immediate and accessible source of energy. When your body breaks down glucose, energy is released in the form of ATP, which your glucose needs to perform the majority of their operations.
Yes, and of course, just like how all things cannot be eaten, all carbs cannot all be break down as well. For instance, indigestible carbohydrates that mostly pass through the digestive tract undigested make up dietary fiber. Despite not being digested, fiber is essential for bowel regularity and the growth of good gut bacteria, which both promote the maintenance of the intestinal health or excreted in feces or absorbed into colon cells, with a small portion transported to the liver.
So to sum it up, the digestion and absorption of carbohydrates involve a series of enzymatic actions such as salivary amylase, pancreatic amylase, and Rushford enzyme to catalyze or speed up the hydrolysis of carbohydrates that break down complex carbohydrates into absorbable monosaccharides. This process is essential for providing the body with energy it needs to function properly.
I think that it's a lot to process, right?
Thank you for having us.
Good morning, viewers. Tonight's Science Spotlight is a sweet treat for your brain. We're delving into your favorite sugar snacks become the energy that fuels your day. The secret, a cellular marvel called glycolysis.
Right you are. Glycolysis is step metabolic valves taking place in your cell's cytoplasm. It transforms glucose into pyruvate, setting the stage for energy production. But the plot thickens beyond just fueling your cells.
Indeed, from each glucose molecules, the cell nets to ATP molecules, the cell's energy currency. Plus, it produces two NADH molecules, which are DIPs for energy generating stages.
Here's a fascinating nugget. Glycolysis is an ancient pathway dating back billions of years, making it a shared heritage across life forms, from bacteria to the blue whale.
It's a testament to its vital role in life. And fun fact, glycolysis doesn't always need oxygen. In its absence, cells switch to anaerobic respiration to keep the energy flowing.
Quick recap for our home viewers. Glycolysis starts by ingesting two ATP molecules. Think of it as a small deposit for a larger energy withdrawal.
And in this molecular saga, intermediates like the 3-phosphoglycerate play critical roles, though often unsung in the grand scheme of cellular metabolism.
Let's briefly touch on the 10th step of glycolysis without getting too technical.
Glycolysis is the process by which one molecule of glucose is converted to two molecules of pyruvate. Why is this important? Our objective is to harvest energy, and when we oxidize glucose, we produce energy. It involves 10 enzymatic reactions, and we can break it down in two phases. First, glucose enters the cell via blood transporters. We're going to add a phosphate group so that glucose can't leave the cell. The first phase is the preparatory phase, which is steps 1 to 5. This is the investing stage. ATP is required. Output equals input. The second phase is the payoff phase. It's time to capture energy in the form of NADH and ATP. NADH is an important electron carrier. It's important in ATP production. So then we've used one glucose molecule, 2 ATP, and 2 NAD+. And we've made 2 pyruvate, 2 NADH, and our net ATP yield per one glucose molecule is 2 because we invested 2 ATP.
Good morning, Philippines. I'm America Trina Villalarde. For today, I'm gonna tell you some trivia about the fate of pyruvate. Fate of pyruvate. It is generated during the glycolysis, depends on the presence or absence of oxygen. There are 3 common fates of pyruvate. The first one is aerobic respiration. The second one is anaerobic respiration, and the third one is anaerobic respiration. And some are lethal, like alcohol, fermentation, and yeast. So, first one, the aerobic respiration, it occurs if oxygen is present. At the end of glycolysis, pyruvate molecules are carried into mitochondria. Pyruvate, the main product of glycolysis, needs to alter in order to move on to the next pathway. Pyruvate will be converted to a 2-carbon molecule in the mitochondrial matrix by taking out a carbon dioxide molecule. This generates NADH as well. The 2-carbon molecule interacts with an activated group called an coenzyme A, which is derived from vitamin B5. The end product is acetyl coenzyme A. The second thing of pyruvate is anaerobic respiration, producing ATP in the absence of oxygen. A glucose molecule undergoes glycolysis to yield two pyruvate molecules, two ATP molecules, and two ATP NADH molecules as a result. When you exercise, your own muscle cells and building bacteria like Lactobacillus engage in a form of anaerobic respiration called lactic acid fermentation. Keep in mind that the presence or absence of hydrogen ion depends how lactic acid and lactic wafer is structured. Lactic acid is present as a lactic ion at physiological pH. The process of lactic acid fermentation transforms 3-carbon pyruvate into 3-carbon lactate and restore NAD ion, enabling glycolysis to proceed with producing ATP under low oxygen circumstances. To enable ATP synthesis to proceed, regenerating NAD ion is necessary because the oxidizing agent supply is limited to each individual cell. The third rate of pyruvate, which is anaerobic fermentation in yeast, the alcoholic fermentation in yeast, in other terms, like in bacteria and muscle, the goal of fermentation in yeast is to increase the amount of NAD ion available for glycolysis. There are two steps process are involved in this. The first one is the pyruvate is initially transformed into acetaldehyde by the enzyme pyruvate decarbonylase in the process of alcoholic fermentation. In the second step, alcohol dehydrogenase reduces acetaldehydes to ethanol while generating NAD ion. The glycolysis process can be carried out using this regenerated NAD ion. So, corn and other plants ferment this alcoholically to make ethanol, right? The rising process of bread dough can also be explained by this fermentation. So, alcoholic fermentation is the process by which yeast in bread will create carbon dioxide gas. The gas creating bubbles on it. Additionally, when the bread bakes, the bubbles leave behind tiny holes that contributes to its fluffy and texture. The tiny holes in bread are caused by carbon dioxide gas. Yes, related alcoholic fermentation created the carbon dioxide gas. Summary the discussion for today. The pyruvate is changed into acetyl coenzyme A in the presence of oxygen. That's the first phase of pyruvate, the aerobic respiration. The second one is pyruvate is transformed into lactate in the absence of oxygen, which is called anaerobic respiration. And the last is anaerobic respiration is a microorganism like alcohol fermentation in yeast. Pyruvate acid ferments into alcohol and carbon dioxide during the alcohol fermentation process. Yeast and certain bacteria play a part for this kind of fermentation. So yeah, that's all.